From emails to voicemail to messaging, we are used to receiving information asynchronously and grateful not to have to pre-plan a schedule for every single time someone wants to talk to us. In the world of Google Cloud data engineering, the PubSub service functions as an asynchronous messaging tool that allows for data to be retrieved on demand rather than on a schedule. In this course, I'll explore the benefits and concepts behind PubSub messaging queues and the difference between PubSub and PubSub Lite. I'll also cover how to build a PubSub messaging queue with push, pull, or even streaming configurations, as well as the security components that surround the service. This course is one of a collection that prepares learners for the Google Professional Data Engineering exam. In this video, I'm going to describe the PubSub service and its core components in the Google Cloud. Let's first understand what is a Google PubSub. Google PubSub is just an asynchronous, scalable messaging service that decouples services producing messages from services that are processing the messages. Let's talk a little bit about what that means. First, we understand what a messaging service is. We've seen this before. Anything dealt with emails and text messages, and we know how those work. Somebody produces messages, types it in, hits send, and it could send it to maybe 4 or 5 people if you're in a group chat or something like that. And that's how it works. Now, the idea is that these messages are going to be produced by a piece of code or some type of function or some type of operation that's happened programmatically, and it's going to send it to perhaps maybe 10 or 20 other services. We don't really know. It could be a limitless number of services here. So what this does is it decouples the service that's producing the messages from all the services that are receiving the messages. And this decoupling is what makes it a very powerful tool, because we have this asynchronous communication that's totally scalable. You can have 100 subscribers, 100 people listening to the message, or you can have one, and you're still going to get a 100 millisecond latency between the events. And this is the idea of what these Google PubSubs are. Now, with Google PubSub, here are some reasons why you might use it. I've used it for streaming analytics or data integration pipelines to load and distribute data sets across many different sources. I can also have this as a message-oriented middleware with APIs or some type of client-to-server operation. So think about sending messages between a mobile or web application and a service using products like Firebase Cloud Messaging. This is the idea of what's happening with message-oriented middleware. And so now what I can do is I can have this type of Google PubSub and talk a little bit about what this PubSub actually means. Well, Pub just stands for publishers. These are the pieces of code that are going to send information. They produce messages. And these messages, I think they could be just JSON bodies or some type of formatted text that's going to be sent over to the subscribers. Now, we know that with the JSON body, we're looking for certain keys, and we're going to send that message to a PubSub, and the subscribers to that topic of that message is going to receive it. And this is where we know the subscribers are just the consumers. These are the things that would maybe take this JSON body and parse it and maybe store certain elements of it in a database or Postgres database or BigQuery, for example. And this is the asynchronicity. When the publisher just publishes the message to the PubSub, it forgets about it. It's completely gone. Now the subscriber is going to work with it. And so here are some key PubSub features for this. One of the things that we have is known as horizontal scalability. We have this horizontal scalable system that grows by adding more computational resources so that as we receive more messages, to make sure that we're getting them within 100 millisecond latency, we're going to add more computers, tools for us so that we can actually send those messages to all those subscribers. So it's horizontally scalable, and it's done for us underneath the hood in the Google Cloud. And we have this thing known as a dead letter queue. Now, this is the interesting part. When we send a message to a topic to a bunch of subscribers, what's happening here is that maybe some of these subscribers could fail on that message that we sent. Maybe they open up the JSON and there's, I don't know, some runtime error that happens when they try to parse the JSON. We don't know. If that happens, we need to be able to identify what message caused that runtime error. So first PubSub will try to do is it will try to send the message again to the subscriber just to give it a retry. and then it'll fail again. And if it keeps failing after it's exhausted the number of retries, it'll take that message and send it to what's known as a dead letter queue. This is basically a collection of all of our messages that we've ever sent to let us know that out of all of these are the ones that have failed. And then we could take a look at them and maybe figure out if there's some erroneous problem that's happening on the publisher side or the subscriber side, or there's some type of uncaught exception that we weren't looking for. And so then we'll have even more powerful, we have something known as filtering. We can actually filter certain messages happening in the queue. And this is really useful for that. If we're only going to send messages that have certain topics, certain keys in the JSON field, for example, we can filter those out. And we have this known as per message parallelism. So this means is that PubSub is going to lease our individual messages to subscriber clients, and this is where it's going to track whether a given message is successfully processed or not. So it's going to lend it out to somebody else, to a service that's going to consume it, and then watch what it does with it. If it succeeds, then it can keep track of what's actually successful and what actually fails. And it's all done for us automatically. All the producer has to do is just send this message out to a PubSub, and the subscribers and Google PubSub will take care of the rest. Here are some typical PubSub use cases that I've used this for. I've used it for ingesting user interactions from web applications or mobile applications, real-time event distributions from Internet of Things devices. We have message replicating data, which is quite useful so that as data is entered into one table or one database, I can then send that same data to another system. I've also used it for parallel processing systems and workflows where I can distribute many tasks across multiple workers by using PubSub messages to communicate with the actual workers that are receiving the messages. So this could be things like compressing text files, sending email notifications, evaluating AI models, reformatting images. Those are really what they're used for. We have an enterprise event bus. So I can actually create some real-time data sharing, distributing business events, database updates, analytics events across an entire organization. Data streaming for applications and IoT devices is, again, a very powerful tool here. We also have refreshing distributed caches. So an application can publish invalidation events to update the IDs of objects that have changed. And we also have load balancing for reliability. So instances of a service may be deployed on a compute engine in multiple nodes. And then I can subscribe to that same common topic. And then when the service fails in any zone, then others can pick up the load automatically without causing any issues. So that's the interesting thing there of having this kind of load balancer tool for this. We can also just talk a little bit about this. I've already talked about one of them is called the topic and a bit of the message, but let's say a topic is just a named resource to which messages are sent by publishers. A subscription is where a resource representing the stream of messages from a single specific topic, and that is going to have the subscribers to that subscription. And then we'll have a message system, the combination of data with certain attributes that a publisher will send to a topic is delivered to those subscribers. So it's just a message. And a message attribute is just a key value pair that a publisher can define for a message. So I can have some type of JSON body with a key value pair in it and then send that over. A publisher, this is an application that creates and sends messages to single or multiple topics, and a subscriber is an application with a subscription, which again is just a stream of messages from a single specific topic. We'll also see this called acknowledgement or ACK. This is a signal sent by a subscriber to Google PubSub after it's received a message successfully, and these acknowledged messages are removed from the subscription message queue after a while. And then we have the push and pull. So push and pull are the two delivery methods when it comes with PubSub. So a subscriber receives a message either by pushing them to the subscriber's chosen endpoint or by subscriber pulling them from the service itself. So think about polling. A subscriber could be, instead of waiting for the messages, it's going to maybe check every few minutes, every few seconds to see if the message is there, or it can actually push it. The PubSub topic can actually push this out to all of the subscribers. So both of them are okay. Now, remember, this publisher-subscriber relationship is typically used as a one-to-many fan out, or you can have a many-to-one, which is a fan in, and you could have a many-to-many relationship. So you could have one producer, many subscribers, many producers, one subscriber, or you can have many producers and many subscribers. And that is the difference here. Those are some of the key concepts for Google PubSub. Let's talk a little bit about their integrations that you've seen them used before. You could see them used in stream processing and data integration tools. So we'll use them with things like Dataflow and Apache Spark in particular. We'll use it also in monitoring, alerting, and logging. So there's different products that you can actually use with alert when a certain event happens in your log scheme. For example, a server 500. Maybe you want to let somebody know. Maybe we should do some special thing with that information. This is where we can actually leverage Google PubSub, and we can use some of the third-party tools that are available, such as Grafana or some type of monitoring tool of your choice. Authentication and identity access management. This relies on the standard OAuth authentication used by other Google products, just like we've used anything in the Google Cloud. And this is to enable access control for individual resources. We'll have things like APIs, which are PubSubs used to create these things, along with client libraries for several languages. So we can actually bring those libraries into a programming language of our choice, such as Python or JavaScript. There's triggers, notifications, and webhooks that are useful. So we can actually do a push-based delivery of messages as HTTP post requests to webhooks if we choose to. And we have something known as orchestration. So PubSub can be integrated into multi-step serverless workflows. And so big data and analytic orchestration can work with Cloud Composer. And we can actually work with integration connectors. So these connectors let us connect to various data sources. Could be BigQuery, could be an external tool. With connectors, both Google Cloud services and third-party business applications can actually receive this interface. And so you can actually create a PubSub connection for use in the integration section. It can work with third-party tools as well, not just other Google Cloud services. So that's a little bit about Google PubSub, some of its key concepts, and its use cases. In this video, we're going to compare and contrast some of the PubSub and PubSub Lite features. Okay, so there's two main services for our PubSub. We have PubSub and PubSub Lite. PubSub is typically that's used for applications with integration and analytics. And you'll find that PubSub Lite is recommended when there's message throughput is stable and the cost is a key issue. Things that you're trying to look for cost saving measures, I'd use PubSub Lite. But for heavy duty or typical application integration and analytics use cases, I'd use the regular PubSub for this. Now PubSub just offers more features. So you have this per message parallelism, comes with global routing, and automatically scaling the capacity resources for actually sending messages to many different locations. And it has synchronous replications. It's all guaranteed by synchronous replication there. Now, the PubSub Lite will trade certain features for the cost efficiency. And this is where you're going to have partition-based messaging, and you're going to have manual resource capacity management, instead of it being automated like with regular PubSub. And you have to choose from zonal or regional Lite topics. And so they offer the same availability, service level availability as their PubSub topics, but they're a little bit different. They're only on the zonal or regional Lite topics. Now the reliability is a little different. So, PubSub will support synchronous data replications, and it does this by using 3 zones. Whereas regional Lite topics replicate data to a secondary zone. And the zonal Lite topics replicate data in a single zone. So think about kind of your fault tolerance for these topics, for these things that you have. Usually what's going to happen is with regular PubSub is you're going to have fault tolerance because you have it replicated across 3 zones. But if you go down into a regional Lite topic, you get it over 2 zones, and the zonal Lite is very little fault tolerance with just a single zone. Now, how do we choose a solution? Well, there's some business requirements that we have to kind of go through. So with PubSub, we want to start asking ourselves some questions. Is reliability important for us? Or is this going to be a business critical infrastructure that we need to build? We have a minimal operational cost that we're trying to reach. Is there some type of cost that we should be worried about? And then we have to be able to look at the simplified development measures. Or is that really important for us to save some money on the simplified development by paying for this feature set that comes with PubSub? Now we can actually ask ourselves the same questions with zonal Lite. How tolerant are you to risk? Are you willing to incur some additional operational overhead in managing the topic capacity? Can you work with availability risks and inherit zonal services like we're seeing? Do you require low cost for this project? Then you should probably use your zonal light. When we're working with regional light, the questions you want to think about is protection against zonal failure. Do you require that protection from zonal failures? Are you willing to incur an additional operational overhead in terms of managing your topic capacity? Or are you just looking for the lowest per throughput cost? And this is where I would use the regional light topics. Now, some key considerations for choosing a PubSub solution. One thing I look at is what you have here in the tables. We have like data replication, message routing, resource namespace, capacity management, delivery modes, parallelism, and streaming pipelines. So if we're talking about data replications, we're thinking about, do we want these topics to replicate data to 3 zones within a region? Maybe that's a little bit overkill. Talking about PubSub Lite here, you'll think about, can we have some type of data to go to 2 zones instead within a region rather than 3? And then you can go to zonal PubSub Lite topics, which store data in a single zone within a region. So obviously the zonal one is the cheapest. And so it's something to think about when you're actually trying to design your system, is what service do I need and what features do I need to actually make this work? Now, message routing, is you'll notice with both PubSub and PubSub Lite, they can publish and subscribe from all regions and even outside of Google Cloud, which is great. And then the PubSub route messages, all completely global. And these are just some of the things I'd bring up. One interesting note I'll also talk about here is the idea of our delivery modes. You'll notice that regular PubSub will support multiple message delivery modes. This is where we'll have things like traditional polling with pull, or we can use push with HTTP post, or we could have a bidirectional RPC for lowest latency and high efficiency. Those are all supported by regular PubSub, and depending on what protocol you want to use, you may have to resort to using regular PubSub. Now, the parallelism here is PubSub uses a per message parallelism. This just means that we're going to enable concurrent processing of any number of messages from one or thousands of clients for a single subscription. PubSub Lite will use partition-based parallelism rather than per message parallelism. This means that the client is going to be forced to process each data partition in a linear order on a single client. So this is going to limit your maximum number of clients at most that can be reading from a topic. So that is a little bit of the difference between these considerations for choosing a solution when it comes to what type of PubSub do we want to use. There's a lot to this, and it depends on the system and your business use case that you're trying to build. In this video, we're going to identify the main steps that are involved in configuring PubSub using the Google Cloud Console. Let's first understand how we can set up PubSub. Before we do that, make sure that we have our identity and access management configured properly. So when we're trying to get access control with our IAM, we want to start with accessing on a per topic or per subscription basis. It needs to be granted to our user or our service that's going to be consuming or publishing the message. So in PubSub, this can be configured at the project level. So you can grant access on topic or subscription rather than the whole cloud project itself. And this all can be done either with the Google Cloud CLI or in the Cloud Console in the Identity Access Management portal. You can grant access even with limited capabilities so that service or the user can only publish messages to one topic or a couple of topics or a group of topics. Or you can have them only consume messages from a subscription, but not to delete the topic or the subscription, which is also necessary for this. We want to make sure that they have access to all resources in a project or a developer group. So all PubSub resources within a project or developer group can be given access to a user or a service. It's up to you on how you want to actually set these things up. But those are basically the 3 options on how you can handle these things. Now, how do we authenticate to PubSub? So we have 2 ways that we can handle this. We've got the programmatic authentication, which involves getting some API access, some client libraries to provide high-level language support for PubSub programmatically this way, and it's fine for this. And this involves actually getting the client libraries for the programming language that we're working with, whether that's Python or JavaScript or C#. We can actually just download the library and authenticate there programmatically. Or we can actually use Google Cloud CLI, and we can actually handle this in REST. And so this is going to, again, use some of the client libraries there or some of the APIs endpoints that are created for PubSub through the PubSub API. and use our CLI credentials to actually do the operations that we're looking to do. Now, we're going to be sending messages to a topic, and that's fine. We're going to publish messages there. So we have to encrypt the messages with a Google managed, which is our default key, or a customer managed encryption key. Those are the two encryption keys that we can use. There's no setup or configuration that's required for us if we're using the Google managed one. It's for most use cases, that's plenty of encryption. You're going to be fine with that. But this allows us to encrypt our information at rest once it gets to the actual destination. But it also allows us to encrypt it in transit. So PubSub can individually encrypt our incoming messages as soon as the message is received. And this is where we can actually do this no matter what, whether that's storing it or sending it to the actual hardware, so it's at rest, or it's in transit, sending it through HTTPS. Now, to get started with PubSub, we need to make sure that we have our Google Cloud account that's already been created, and we just have to have a Google Cloud project, and that's pretty much it. You can actually use some of the free credits that Google Cloud offers you to actually experiment and test out some things with PubSub, and then you are ready to just start to enable the PubSub API for that project. Now, how do we actually create a topic? It's the first step in creating a topic is done through the Google Cloud Console by going to the PubSub page. In the topics section there, you can actually just create a topic where you can give it a topic ID field and just store some information, some metadata on the topic that you're going to be creating. And then what you want to do is you want to be able to add a second subscription. So to add a subscription to the topic you just created, all you got to do is just, again, click the subscription page in the PubSub page and then click create subscription. And now all you have to do is get the subscriber. This could be a cloud function, or it could be potentially sending a text message or an email. It could be anything like that. That's going to be a subscriber to this message. And then you just have to create that there and tell it what topic to listen for. After those two things are set up, all you have to do now is just publish a message. And so this can be done actually in the console. You don't actually have to write code for this. You can go to the PubSub topics page, go to the topics, and then in the topic that you created under the messages tab, you'll see a button that says publish message. And then all you have to do is a little window will pop up in the message body window, enter a string that you'd like to send. So send the word hello world, click publish, and a message will display at the bottom of the page. That tells you that the message has been published. And just like that, you've created your first message to that subscription. So now that's working, like we just published it to a topic, right? What are the two ways that the server can receive it? So we can pull messages from a subscription. So if we're doing a polling kind of thing, all we got to do is we can do that in the Google Cloud Console. So if you go to the subscriptions page, in the messages tab, click pull, and there you should see the message that you just published. And the message has data like hello world that you could have typed in, some type of string, and when the message was published. So not only do you see the content of the message, but you'll also get a timestamp for it. After that, once you're done experimenting with these things, you could just clean up by deleting the subscriber, deleting the topic, and then that would be it. And then you're back to normal. Now you've kind of experimented with the idea of using PubSub in the Google Cloud Console. Try to see if you can do the same operations, but with a programmatic way rather than using the console itself, using a Python library, and you could see the same kind of steps are involved, just using a different syntax, or I guess just different tools completely for that. Okay, so that's a little bit on Google PubSub. In this video, we're going to describe some additional steps that are needed for security and control access with PubSub. So when we're talking about publication as subscriber messaging in Google Cloud, what we're talking about is really we want to be able to control the regions where the messages are going to be stored. See, we're going to be sending messages to a topic, and sometimes we're going to need to store exactly where those messages to that topic are going to be located in the world. So primarily all of these storage policies are going to be used with the console, or the Google Cloud Console, or Google Cloud CLI, or using the PubSub REST APIs that are available. Let's just start with a little bit of a brief overview on how we can actually create topics and just some general concepts here when it comes to publishing. So when we publish a message, we're publishing a message to a topic, and a topic has many different subscribers. It could have many subscribers. And we first have to create the topic, and we can do this directly in the Google Cloud Console or the CLI or its REST calls. And we want to have some properties on those topics. Now this name resource is going to represent just a feed of messages. So when a publisher sends a message, it targets a specific topic, and this service, the PubSub service, is going to use this topic to route the messages to all the subscribers that are attached to it. Now there are different types of topics that we can create. We can create normal topics, but there's ones called import topics. An import topic lets you ingest data from external sources into PubSub, and then you can stream the data into any of the destinations that PubSub supports. So PubSub can support things like Amazon Kinesis Datastreams, for example. This is an external source for ingesting data into an import topic. Now, an import topic just means that it has its ingestion enabled on the topic, and this lets us import topic ingest streaming data, and we can enable ingestion on a topic by using the console or the Google Cloud CLI or any of the client libraries. And this is just part of managing the topic. You can actually use Google Cloud will provide some type of monitoring and scaling of this ingestion pipeline that you want to use. So everything that we're dealing with, whether it's an import topic or a regular topic, involves publishing messages to these topics. And then after these topics are created, we get to manage them. And so we can actually scale them, or we can actually change their names or change their properties on them, or any type of attribute that's associated with this. Now, when it comes to a PubSub publishing configurations, there's things like we want to be able to do. For example, one of the most common things that we could do is called compressing messages. Now, when we compress a message, we're doing it to save on space. We're saving size and therefore just kind of reducing our networking costs for actually sending messages. So we can use the gRPC format to compress our data to save networking costs before we actually send information to our publisher. And we'll notice is that there's going to be some retry requests. So sometimes we'll have retries available. So publishing failures are typically caused by client-sized bottlenecks or insufficient service CPU, or there's some bad thread health or some type of network congestion. There are times where when we send a message, it could possibly fail. The publisher retry policy is going to tell us the number of times PubSub could try to deliver a message and the length of time to wait between each attempt. So this means that if something were to fail, we'll try an initial request timeout, for example. We'll have some type of wait 10 seconds or 20 seconds to actually retry the message. And if that doesn't work, we'll actually move it to what's called a dead letter queue. Now, there's one more thing that I want to talk about, the concept of flow control. Now, it's difficult, I think, to wrap your head around right now because it's not a concrete example. But if you think about the publisher as just a computer creating messages, and it's sending those messages to a topic, which is another computer that sits there. There are times where the client could have a machine CPU or RAM or its network capacity. Those could fail. That's just one of its limitations. You can have its network settings, such as the number of outstanding requests and the available bandwidth. That could fail. So what we want to do with flow control is allow ourselves to mitigate flow rate issues. So we can configure our publisher client with flow control to limit the rate of publish requests so that it doesn't flood the topic. So you can configure for example, the maximum number of bytes that are allocated to outstanding requests so that we're not going to actually be dumping a whole bunch of data all at once and potentially overwhelming a machine and causing it to lock. And this is where we'll have things like concurrency control in place. And so it helps us override the default number of background threads that's used by the client library to publish the messages. And we'll have things like batch processing. So instead of dumping one message at a time, we can actually batch our messages together. And so those settings can be changed with the topics to the point where with our publisher so that we can say, okay, just, take 10 messages, group them together and send them over, or 100 messages, group them together and send them over. And so there's different ways to do this, but it involves programmatically doing this on the client side that's publishing the messages. And then you'll be able to send 10 messages in one pack to the topic. Now, there's a couple of things that I want to also bring up here so we can to publishing some of our best practices that we want to handle is we can attach a subscription or enable topic retention before publishing. Configure your batch messaging if possible. It's very rare that you would need to send one message at a time, so that allows you to save on network costs. You can also configure your flow control. You can know your network's bandwidth and latency and reconfigure retry requests. There's another thing that I also recommend is that you can use a message storage policy as well. So exactly how long do you want to store the messages after they've been delivered or after they've been processed? And you can configure ordered messaging so that you'll have the messages in certain sequence. So that could be important depending if you're building some type of event architecture. Let's move on to actually receive them. Now that they're published to a topic, what does the subscriber do? It's looking at this topic, it's waiting for messages. Well, first one, creating a subscriber just means that we have to select a subscription type. So the subscription type here there's a few different ones. For example, there's pull subscriptions, where the subscriber client is used to request messages from the PubSub server. So it's kind of like a poller. There's push subscriptions, where the PubSub server is used to initiate requests to our subscriber application to deliver messages. So that's really what we want to do. Is once we figured out what subscription type, we can go ahead and create the subscription. And creating the subscription can be done exactly through the Google Cloud CLI or the console, or you can actually just do some API requests if need be. So that's that one. And then we can move on to actually manage the subscription. So when the subscriber is ready to go, managing our subscription involves it changing type of subscription that we want to create, or it could be just changing exactly how many times it's polling. For example, maybe it polls every hour, maybe it polls every 10 minutes. You can control all of that in the Google Cloud Console. And then you can actually configure any type of delivery options that it's going to receive. So these delivery options could be exactly what format you're going to be receiving the information in, and that can all be done again through the Google Cloud Console itself. Now, subscriptions, like I said, have a few different types, and we have the pull subscription, which is exactly what it sounds like. It's pulling the information. We are polling the topic every few minutes, every few seconds, whatever period of time that we've configured our subscriber to do. Or we can actually follow a push subscription model, so that the moment the messages happen on the topic, the push subscriber is then going to send the messages over to the subscriber. Another thing that you could have is called a BigQuery subscription. So BigQuery subscription is a type of export subscription that writes messages to an existing BigQuery table as they are received. So you don't even need to configure a separate subscriber client. You can use the Google Cloud Console to set this up. But this way, it allows you to create, update, list, or detach or delete a BigQuery subscription all through there. And this is really the interesting thing, is that we can use BigQuery to actually store the messages for ourselves so that it's receiving the messages and storing them for us. Another thing that's useful is you can have cloud storage subscriptions. This is a special type of subscription that's meant for a bucket on Google Cloud Storage. And so what this could do is every time a file is created inside of a folder in a bucket, we can actually trigger a PubSub. We can send this event into a topic, and some subscriber would listen for that topic and then do an operation perhaps on the file that's stored in the Google Cloud Storage bucket. So that's kind of how that works. There are some subscriber best practices that I want to discuss here just briefly. We want to make sure that we're selecting the right subscription type, whether that's a pull or push subscription type. We want to also see if we can process messages prior to the acknowledgement from the server. So that's important for this as well. Another thing that I recommend is, with our prior acknowledgement here, by default, what's going to happen here is PubSub discards a message from subscription after the message is acknowledged. But what happens if you don't process a message before you send that acknowledgement and the processing fails? What happens is the service does not redeliver the message at all. So what you want to do is you want to have an exception when you have configured this acknowledged messages or topic retention. So I can go back and see this message failed, but I have a backup of that message. I can resend it to a subscriber if I need to, just have some type of record for this. And then I can have configuration of the flow control for transient spikes. So flow control on the subscriber side just lets us prevent subscribers from being overloaded by traffic spikes. It can allow time for auto-scaling mechanisms to respond to and an increased load, or it can spread the processing the load over a longer period of time. And we can have configured ordered messaging. This is important as well. Now, this all depends on whether you choose either streaming pull or pull subscriptions. For a push subscription, PubSub supports only one outstanding message for each ordering key at a time. So sending parallel push requests in such a scenario would be similar to sending multiple batches of messages for the same ordering key to pull subscribers simultaneously. Or we can enable messages that are ordering in the subscription. So on the publisher side, if you send messages with an ordering key in the same region, you can configure this subscribers to receive those messages in order, or you can acknowledge the messages in order as well. Those are some of the best practices for ordered messaging. This is how we can configure ordered messaging for this. Ordered messaging is important for event architectures. If you're not really worried about ordering of what message gets processed in what order, you don't really have to worry so much about this, but it does affect certain architectures or certain business practices that you may be trying to follow. So that's a little bit about subscribers and publishers and some of their best practices. In this video, we're going to identify when and how these optional features of schema should be included and applied in a PubSub configuration. Let's first understand what is a schema when it comes to PubSub. A PubSub schema is an optional feature that we can use to format the data of the PubSub messages. And so there's a data field inside of the PubSub messages, and we want them to have a particular schema or a format, and so we can enforce it with this feature attached to the publisher subscriber model. Now, all the schema is doing is it's creating a contract between the publisher and the subscriber about what formats of the messages that are going to be sent back and forth. This is going to enforce the format for us. And so what will happen is that schemas will facilitate the consumption of our data streams, and it'll create a central authority for what message types and what permissions they'll have. And this is going to define things like the names and data types for the fields in a message for us. Now, there's different schema types that we have. There's Apache Avro, and there's the protocol buffer. And you can actually even delete a schema or delete a schema version. So, if I want something in an Avro format and the protocol buffer format, I can actually use different protocols or Apache Avro. In fact, Avro version 1.11 is supported, and protocol buffers Proto 2 and Proto 3 are supported as well for those formats. Now, there are some quotas and there's limits. So there's a maximum of 50 kilobytes definition per field. So each field can only contain 50 kilobytes of data maximum in size. There's a maximum of 10,000 schemas per project that we can use. So anything greater than that, you'll have to contact your Google Cloud provider and see if you can actually increase that schema limit. Now, a single schema can have many different revisions, but it can't have more than 20 revisions per schema. So how do we actually use these schemas? Well, the first thing we want to do is we want to create a schema. And so this is where we need to make sure, first of all, that we have the proper roles and permissions on our IAM role for the project. And once we know how to do this, we can go ahead and create the schema, and we can use the Google Cloud Console, the G-Cloud CLI, or we can call the PubSub API directly, or we can use a Google Client or Cloud Client libraries, such as the ones for Python or JavaScript. After we do that, we can associate a schema with a topic, which is important. And so we can actually have a Avro schema and associate that with an actual topic. And then all subscribers to that topic will be receiving that message in that format. You can publish your messages to a topic with this schema, and then all subscribers will be able to consume those messages. There's different schema management options as well that are there. We can commit, for example, a schema revision. Maybe I'd like to change the format of a particular field, so I'll make a different version of that same schema without creating a brand new one. I can actually delete old schemas if I don't need them, or I can even delete schema revisions on that schema layer itself. Another operation is maybe I want to be able to list the schemas either in the Google Cloud Console or through the CLI. And I can even list schema revisions for each individual schema. And these are just some of the management options that are available to use with Google Cloud when it comes to schemas in PubSub. Here are some more schema management options that are useful. Perhaps I'd like to roll back to an earlier schema revision. Say I made a revision to version 2, and I'd like to go back to version 1. Well, I can do that in the Google Cloud Console or through the CLI. I can even look at the schema details in depth, and I can actually validate the schema definitions. This is really important. It's allowing us to actually make sure that the messages we're sending to the topic are actually exactly what the schema is expecting. If it's not, then it won't actually publish to the topic. We can even validate messages for our schemas this way, and this is one way that we can do that is using the schema definitions that are defined and make sure that the messages are validated. So that's a little bit on PubSub schemas and what they are and how we can use them to enforce healthy and clean messages to the topic. In this video, we're going to talk about the purpose of PubSub client libraries and what they are. So a PubSub client library almost just exactly what it sounds like. It's just a programming library for your programming language, such as Python or JavaScript, that allows us to have simplified access to the Google Cloud APIs. This is really important because it allows us to reduce any type of coding or configuration steps that we need to do to call the APIs directly. And we can actually call a simple command in our Python language or our JavaScript language or our Java language to go ahead and do a certain operation in PubSub, such as publishing a message to a topic or receiving a message from a topic. Now, using our PubSub client libraries, pretty straightforward. We want to first install the client libraries through the language's programming package managers, such as the pip package manager or npm for JavaScript. And then we want to be able to set up our authentication. Now that we have the library installed, it's important that we authenticate with the library such that it knows that we are using our credentials in Google Cloud to make these operations to the PubSub. Then we want to use that client library to either create a PubSub topic or start publishing to this language. And it's as simple as that. There are commands to set up authentication in the library, and there are commands to create and publish messages to that topic. And here are some of the supported client library languages that are available. One of them is for C++. Another one is for C#. You'll have one for Go, and there's even one for Java. All of them have their supported client library languages that will allow us to create these PubSub messages and topics. Here's some more that are available. There's one for JavaScript or Node.js, the backend for JavaScript. There's one for PHP, and you'll even find one used, as I mentioned, for the Python library and the Ruby programming language. All of them have their package managers that we can actually use to install this library for us. Now, what does it mean when we have these libraries and what best practices are available? Well, this allows us to reuse client objects and sessions so that we don't actually have to create brand new objects and sessions each time we want to create something. We can create a global variable or a class that just is a singleton that creates a single object or in session for us to use. And then we just retrieve that session and we go ahead and use that session to do any operation in the Google Cloud, including creating PubSub topics and as well as publishing messages to those topics. It allows us to pin dependencies for our production, meaning that we are not going to be upgrading the library for any reason. We're going to go ahead and use these libraries at the particular version for us and not do any types of updates. And it allows us also to stay up to date with the latest libraries when we are in development and we want to go ahead and make sure that we're using the same version. We can make sure that we stay up to date to use the new capabilities of Google Cloud's capabilities and APIs that are available. And so these client libraries could change often, and you might see daily updates or releases, but you want to make sure that you stay up to date in the development version and pin your dependencies for production so that you don't accidentally use new features that are not tested in production. And that is just a little bit of what's available with these client libraries and these programming languages, as well as why we use them and some of the best practices to use them in our code. In this video, I'm going to show you how we can actually publish messages and create messages in PubSub after we've created some topics. Let's go ahead and get started with going to our Google Cloud Console first, and then up at the very top, let's go ahead and actually type in PubSub. And what you should see is pub/sub, and you see global real-time messaging. We're going to go ahead and click this, and we're going to be met with a page that looks like this. We should be at the topics page. So if you go to the left-hand side and underneath PubSub, you should click topics in case you aren't there already. And this is what the page will look like. You can see here I already have some topics that are already created in my Google Cloud project, but I'm going to show you how we can create one brand new from scratch and then attach a pull subscription to this topic. Let's go ahead and click Create Topic up at the very top. And now it's going to be asking us to create a topic ID. Now there's some options here that are useful for us. So let's first just give it a topic ID. I'm going to call it my-topic, like so. And so this is going to be enough for that. And then what I want to do is I want to check the box that says Add a Default Subscription. What this will do is not only create a topic, but it'll also create a subscription in one step that's subscribed to this topic. That will be a pull subscription. That's fine for now. I don't need to enable ingestion or any of these other tools, but keep in mind that I can export message data to BigQuery and store them in its own table. What I'll do for encryption is make sure that the messages are encrypted using the Google managed encryption key. They're keys that are owned by Google, which is secure enough for our use case. Let's go ahead and click Create at the very bottom and give it a moment for the topic to be created. Now, when the topic is created, you should see it in the list of topics that we had at the very beginning, and it'll take you to a topic subscription page. So as you can see here, it immediately took me not just to my topic, which is what I've created, but it also created the my topic dash subscriber for me. So this is a subscriber for those messages. Now let's go ahead and go back to the topics, and I'll show you the actual topic itself and what it looks like on the front page. So if I click topics here and I search a filter by my dash topic, and you can see here's my topic. This is the one I just created. And let's go ahead and click this one. Now I'm met with the My Topic Details page, and there's a few different sections for me that are useful. One is the subscription sections, which shows all the subscribers that are subscribed to this topic. So here I've got one that's created by default, my-topic-sub. Great. Another one that's useful is being able to look at the metrics page. And this allows me to see how much traffic has been attached to this topic. And so that's useful for that as well. Now, if I come over here to the messages section, you can see that I can actually test my subscription to see if I can receive a manually published message. Let's go ahead and do that. Let's go to step 1 and actually click Publish Message. Now at the very top, what will happen here is this little window will pop up and it asks us to see how many messages we want to publish. Let's go ahead and click Number of Messages as to 1. Now I can provide it a message body. I'm going to keep the message body very easy, but keep in mind that the message size should not exceed 10 megabytes. So for now, I'm just going to leave it as, this is a message to my topic. Great. So that's enough for now. Let's come over here. Let's scroll down a little bit. I can also add some attributes, so some key value pairs that are useful to help us read this message if we need to. For now, I'll just leave it like this, and I will go ahead and click Publish. Now, the message has been published. The next step is to actually select our subscriber and see if we can pull some messages from this topic. So this little drop-down menu will list all of the subscribers that are attached to my dash topic. So here's the one that I've just been creating, and I'll click that. And now it'll ask, if I scroll down just a little bit further, you'll see that now there's a section that says I get to pull. Now I get to pull means that I need to pull the topic to see if there are any new messages that are there. I'm going to click the pull button right there. It's going to take a moment for it to pull any information. And you can see that there it is on this date. You can see that it says this is a message to my topic, and it tells me if any other information for such as an ordering key or if there's an acknowledgement that's being sent back. And so that is how we can actually publish messages and receive messages to a Google PubSub topic and a subscriber. In this video, I'm going to show you how we can actually incorporate creating a topic and a subscriber, and then sending any messages that are sent to the topic to a BigQuery table that's already been created. So I already have a BigQuery data set with a table that's empty right now. So I'm just going to start at the PubSub page and click Create Topic up at the very top. I'm going to give it a topic ID. I'm going to call it my-topic-big-query. Like this. I'm going to add a default subscription, and I'm going to select the settings that says to export a message data to BigQuery, like so right here. Now it's going to ask me to select the project of my data set, which is valued, and I'm going to click data set here and click the data, which is sales_data, and then I'm going to provide it the name of my table, which is my-table, like so. Now this should work. Let's come over here. Let's scroll down a little bit, and let's say we're not going to use a schema, and let's scroll down, and we're going to click Create here. We're going to give it a moment to just create the actual topic and the subscription, and it should take us to the subscription page. Let's go ahead and click Continue, and you'll see that there's a my-topic-bigquery-sub. So this is where my subscription lives, which is fine. Let's go ahead and go to my messages section, just like we did before, and let's go ahead and click publish a message. Now, any message that I type in will be sent directly to the BigQuery table. So I can go, this message should go to BigQuery, and I get to actually scroll down and click publish. Now the message has been published. I'm going to select my topic, which is right here, BigQuery sub, and I'm going to click pull. We'll give that a moment, and you'll see that the message has been sent, and this message body will go directly to the BigQuery table that I have specified. And that is a little bit on how we can incorporate the PubSub topic directly with a BigQuery table and a data set that we already have created in our project. In this video, we're going to identify some common issues that can arise with PubSub and how we can actually troubleshoot these things. Start with the general PubSub troubleshooting steps. Some of the most common steps I've seen with PubSub is you're not able to create a topic. And this 99% of the time comes down to your permissions. When you create a PubSub topic, you need to make sure that you have the PubSub editor role on your user for your Google Cloud project. If you don't have this role, it's important that you contact your administrator and make sure that you have the necessary permissions. Another common one is not creating the topic, but creating a subscription. This again requires its own set of permissions. And so this is where we're going to need, again, the same PubSub editor or IAM role on the project. And you'll have to contact the administrator for this. Make sure that you have a specified name for your subscription and you have an existing topic to which you want to attach the subscription to. Another common thing that you might see is that there is a 403 forbidden error. Now, when you have this, you have to make sure that you've enabled the PubSub API in the Google Cloud Console. You want to make sure that your principal that's making the request has the required permissions on the PubSub API resources, especially if you're working through cross-project communication in Google Cloud. And you also want to make sure that if you're using too much of your quota for administrative operations, you might need to refactor the code. If you have some type of administrative operation that is getting this information, it's being used to check for the presence of a subscription before it attempts to consume its resources. That get operation is going to affect your administrative operations that you're allowed to use. So you might have to refactor that in your code to make sure you don't do those kind of operations so that there's no extra administrative operations there that are taking away from your quota. So a 403 forbidden error just comes down to, like I said, that your API is enabled, that you have the necessary permissions on those resources, especially if you're working through cross-project communication. You'll see that 403 forbidden error is quite common, and that's just because two projects, PubSub, is unable to communicate with each other. Another common PubSub topic for troubleshooting is, you have to troubleshoot your standard topics. And so standard topic itself, you could have your high publish latency. So publishing latency is the amount of time it takes to complete a publish request that is issued by a publisher client. And this is usually distinct from your end-to-end delivery latency. This is actually just sending the message to the topic. And so if you're observing this, one thing I do is make sure that you have a message storage policy, because it could affect the overall latency of the request to the topic and the subscription. You may have to modify that message storage policy because it takes time to actually store the messages before sending it off to the actual consumer. And so now you'll have the troubleshooting import topics as well. And so this is where you could be facing a topic where you are sending messages that are greater than the byte count field. So remember, the larger the message, the longer it'll take to actually consume and publish. And so you might see things like stream not found, or you could have a publish permission denied error. All of these things come down to being able to set your permissions appropriately to actually read from another cloud provider, which is what these import topics are for. Here are some more PubSub troubleshooting tools. So troubleshooting pull subscriptions is important. And so this is where you want to look at your oldest unacted message age keeps increasing. This is a critical metric for monitoring the health of PubSub subscriptions. It measures the age in seconds of the oldest message in a backlog that has not yet been acknowledged by a subscriber. So if that continues to increase, you might have to configure your client. And so this is where you'll have client configuration issues, and you'll have your client code and your client health will start to fail. You'll have quota limitations. So verify that you haven't exceeded this PubSub quota or limitations imposed by the hosting service. And that's one of the tools that we use here. Another thing that you might see is troubleshooting your push note subscriptions. So this is where the topic is actually pushing to the subscriber. So push subscribers are a type of PubSub subscriber where messages are sent directly from the topic using HTTPS endpoint. Now the user is going to acknowledge a push message by returning a HTTP 200 response to the push service request. That's how this works. So you want to make sure that you are failing or slow push endpoints. This is the most common error that you'll see. And so if the endpoint returns an error response code, then the message delivery is considered to have failed and is retried later. And this could lead to the endpoint receiving duplicate messages. And so there's different things that you can actually start to monitor, such as your monitor push subscriptions. And what I'll show is some of the common errors that you'll see is like a deadline exceeded response class, which could indicate that the push endpoint didn't respond within the required acknowledgement deadline. And so this is your subscription push request latencies metric is going to help push this latency back. You could have an invalid response class that indicates that the endpoint sent back a response that PubSub couldn't understand or process correctly. These are all common issues that usually just means that you have to monitor how you're consuming those endpoints. Some more troubleshooting steps. So troubleshooting your push payload unwrapping. So what this means is when using payload unwrapping, you'll have some common HTTP status code errors that can occur. So you'll have like a bad request. And this could be due to several reasons where your payload or message data doesn't match the expected request format specified by the HTTP endpoint. You could have the necessary headers to process the request are missing, or you could have an incorrect HTTP endpoint is configured for the subscription. Another thing that you can do is you could have troubleshooting BigQuery subscriptions. Same kind of deal. With these kind of subscriptions, you could have some error from the status code, and you could have something like an unable to create or update subscriptions. And you could have something like that says that the table is not found, or there's a schema mismatch error. Common one that I've seen is due to a service account error. So if you haven't configured your PubSub service account with the right permissions and it's trying to access BigQuery, it's not enabled by default. You'll have to attach BigQuery permissions to get a table or update data to that service account for PubSub. Another thing you can do is, remember, we could also have some type of permissions on the service account where it's unable to see or retrieve any type of file operations in the cloud storage subscriptions model. Again, this just means the same kind of thing. The service account for PubSub will need to have those permissions for Google Cloud Storage in order for it to operate correctly. And those are just some of the troubleshooting steps when it comes to PubSub. These are the most common ones that I've seen, but they're relatively straightforward to fix once you know what the root cause of the errors are. So in this course, we've examined how the role of a PubSub in a data pipeline and the process used to implement PubSub correctly. We did this by exploring Cloud PubSub and PubSub Lite, procedures and advanced procedures and schemas, PubSub client libraries, configuring PubSub, streaming to BigQuery, and troubleshooting PubSub. In our next course, we'll move on to explore how to implement data streams to efficiently manage data flows between various sources and destinations, ensuring seamless integration into BigQuery and cloud storage. You can't make a great meal without getting your ingredients in the pot, and you can't enjoy great data analysis without bringing in data using a service like Datastream. In this course, I'll cover the integral role of Datastream within data pipelines, exploring its primary use cases and how it seamlessly integrates into various stages. I'll delve into the diverse sources and destinations that Datastream can connect with and identify the network configurations necessary for optimal connectivity. By building connection profiles and understanding the lifecycle of a data stream, you will learn to maintain and manage streams effectively. Finally, I'll give you practical experience by configuring Datastream to replicate data into BigQuery and stream data into cloud storage, enhancing your technical proficiency in data management. This course is one of a collection that prepares learners for the Google Professional Data Engineering exam. In this video, I'm going to describe the key use cases for Datastream and where it fits in the data pipeline. Let's first understand what is this Datastream service. Datastream is just a serverless change data capture, or CDC, and it's a replication service. And what this means is it allows us to synchronize our data reliably with minimal latency between two sources. Data synchronization is done with very low latency, and it's done when we are trying to replicate data into BigQuery. So it allows us to take operational databases, put them into BigQuery for our data warehouse. And in addition, it supports things like template integration. So it has different templates for different sources so that it goes to different endpoints if we choose to. One of them could be BigQuery, another one could be another database in the Google Cloud. And it allows us to write, change, event stream into cloud storage. So as the database changes, so think of our transactional databases in an OLTP database, for example, that's attached to an API, and users are constantly changing them, changing records or addresses or whatever they might be changing inside of their application. What ends up happening is as the data changes inside the database, we are going to take all of those changes, this changed data, and send it over to BigQuery so that it either inserts or updates that data in the location. And this allows us to leverage event streams from cloud storage as well. And it allows us to actually use event-driven architectures in our applications. Here are some common features in Datastream. It has a streaming data access from multiple sources, including Kafka. It has near real-time analytics as a result with Datastream for BigQuery. It also very simple to set up with built-in secure connectivity, and you have automatic scaling as well. So this is a serverless platform that scales with the amount of traffic that we're doing. So there's no resource for us to provision or manage ourselves. It's all done underneath the hood in the cloud. And it's all log-based to reduce the load and potential disruption on source databases. There are some elements as well that I want to discuss. One of them is that there's a private connectivity configurations, and this allows us to enable Datastream to communicate with the data source over a private network. And so this communication happens through what's called the virtual private cloud and peering connection. Connection profiles represent connectivity information to both a source and a destination, and this is what's going to be used by our stream. And a stream here just allows us to use the information, such as the connection profiles, to transfer this change data capture and backfill data from the source into the destination itself. Here are some key benefits of using Datastream as well. We have a seamless ELT process pipeline set up. There's no resource to provision or manage. It's easy to implement, set up, and monitoring can be done in one service. Data integration across Google Cloud data services, including BigQuery. We have synchronization and unification of multiple data streams, security and privacy options, accuracy and reliability, and there's multiple use cases, including things like analytics, database replication, synchronization for migrations, and even hybrid cloud configurations as well. Here are some data stream use case examples. Say that we want to replicate and synchronize data with minimal latency. So you can synchronize data across heterogeneous database and applications reliably. And there's a minimal impact on the performance of the source of the data, which is really important. It allows us to scale up or down with a serverless architecture as well. And there's an integration with Google Cloud Data Integration Suite. So I can connect data across my entire organization with Google Cloud's Data Integration Suite of products. So it'll leverage things like data flow templates to load data into BigQuery or Spanner or Cloud SQL, and it can work with many different database tools as well. And so that's a little bit about Datastream and some of its use case examples, as well as some of the benefits. In this video, I'm going to describe the available options for sources and destinations of Datastream configurations. So we have Datastream sources, which include things like changes coming from a database such as MySQL, Oracle, and PostgreSQL databases. And this doesn't matter if these databases are hosted on premises or they're hosted in the cloud on a self-managed virtual machine. These could be our Datastream sources. Doesn't matter what RDBMS we're using as long as it's one of these three. Let's talk a little bit more about what's going on inside of these Datastream sources. Now, there are different services that are available. One of them is Cloud SQL, and we have also the Amazon Relational Database Service, or RDS. These themselves, these services, even though one's in Google Cloud and the other's in Amazon Web Services, we can actually retrieve this information across clouds or across services and put them into a BigQuery table, for example, and this can all be done inside of Datastream. And one thing I'll also mention is that there's Datastream destinations. So obviously Datastream is great at doing this change data capture between the sources, which could be an RDBMS on hosted premises or in a virtual machine on the cloud somewhere, or it could be one of the services on Google Cloud or even another cloud provider such as Amazon Web Services. It has to send that data to a specific destination. So what destinations are supported? Well, the destinations are BigQuery for one of them, and the other one is cloud storage. So I can actually send information to a BigQuery dataset and table, or I can send the information into files or dumps into a cloud storage bucket. Here's some talking about BigQuery destinations. It means that we first have to configure our destination datasets. So we have to create a dataset, and then we need to discuss the write behavior. So Datastream is going to append what's known as a struct column, and this is called the Datastream metadata to each table that's written to the BigQuery destination. So if we have a primary key at the source, and the column contains the following fields, such as UUID, which is their data type, and we have a source timestamp, and this field has the integer data type. And so we're going to make sure that those two behaviors are going to show up in the metadata column for us. And this is the same thing for a primary key that contains an additional field, such as is deleted, if we're trying to delete an operation. So now we have a write behavior that's set. There's going to be a metadata table attached to the data stream inside of each table. And what we're going to do here is then look at the BigQuery max staleness option. So this is what's known as a data staleness limit. So BigQuery is going to apply source modifications in the background ongoing basis, or during query runtime when you need the information, or it's according to the configured data staleness limit. What this means is that Datastream is going to create a new table in BigQuery, and this is going to have the max staleness option that's set according to the current staleness limit value for the stream. This means that how does this limit happen after a certain amount of time? We're going to update this information using the changes coming from Datastream. There's also map data types. And so a map data type just means exactly how do we map a data type from one of these services, such as Postgres or Oracle or RDS or Cloud SQL. How do we map them over into the data types that's supported by BigQuery? And there's a way to handle that as well, and that's dependent on the system that you are migrating from. And there's some limitations. Some of these limitations can include, for using BigQuery as a destination, you can only replicate data into a BigQuery data set that resides in the same Google Cloud project as the data stream. So if a table in the source database has a primary key, for example, and you'll notice that there's going to be a change in the table so that the primary key is different, data stream can't stream this change into the destination, unfortunately. So that's one of the limitations, just to have an idea for it. You'll notice that it doesn't support more than 4 clustering columns, and there's a few other specific limitations when it comes to mapping out of range date and time literals from PostgreSQL, and that just comes down to the specific data that you're housing in a PostgreSQL database. Here's some cloud storage destinations that we can go here. So one of them is that we want to make sure that we're enabling the application programming interface, or the API. So the Datastream API is really sufficient when the destination cloud storage bucket is in the same project as our Datastream. We'll make sure that that's there. Another thing that we can do is specify destination bucket, and specifically the prefix where all the information is going to store inside of that bucket. So a prefix would be something like the name of the bucket, and think of a prefix as a folder inside of the bucket, and then inside that would be an object name and maybe a date, some type of behavior that you want to actually make sure that you have defined. And this is the write behavior of it. So like the object name and the path for our database sources is the schema. And so when I give it a path name inside of that bucket, that is the write behavior I expect. So for backfill events, the timestamp will represent the time when the backfill task was started. Or for change data capture events, the timestamp could represent when the record was changed on the source. So this all kind of depends on the write behavior that I set when I'm trying to move data from a database with Datastream into a cloud storage bucket. And those are the 3 main pieces that you should have already defined. And it depends, again, on the business use case that you're trying to solve. So that's a little bit about cloud storage destinations and BigQuery destinations when using Datastream. In this video, we're going to identify the available network options for creating connectivity between our sources and destinations inside of Datastream. Let's first understand how this Datastream network connectivity works. So to use Datastream, we have to create a stream from the source database to the destination. And so we have to make sure that the connectivity to our source database must be configured first. After this, you're going to have an IP allow list, or you could forward an SSH tunnel, or you could use a VPC where there's peering networks that are supported. All of these methodologies are ways that we can create this connectivity to our source. And we can then use an IP allow list. To go into a little more detail here, it just means that we can configure source database server to allow incoming connections from certain IP addresses. So this means that the source database is exposed to a public IP address. And this could have, it's easier to configure, but it's also available to the public on the internet, and that kind of causes its own downfall. And so the connection isn't encrypted by default either, so SSL must be enabled on the source database to encrypt the connection. So there's a little bit of extra steps to make sure that it's as secure as possible, but this is not the most secure way to handle it. This is working by configuring the source database server to allow incoming connections from a Datastream's public IP addresses. And you can actually determine what your IP address just is on the details page of your database, but it's a bit of a problem there as well. So when to use your IP allow list? You could use this as an external source database is being used, such as one from on premises or one that's in another cloud provider, for example. So if your source database is external to Google Cloud, then using Datastream's public IP address as an inbound firewall rule to the network is good. You can actually make sure that there's an externally accessible IPv4 address and TCP port on the system that you're trying to access. So you can also use a forward SSH tunnel. So this allows us to establish an encrypted connection over public networks between Datastream and the source. And you can do this through this tunnel advantage. Now, this is much easier. It's a lot more secure than the IP allow list is, but it has some disadvantages. So there's a limited bandwidth, and you have to set up and maintain the host appropriately. So that is a bit of a problem there, but you do get more security, but with limited bandwidth, which might be okay for your use case, depending on what you're doing. So using an SSH tunnel just involves choosing a host that's used to terminate the tunnel. So this is going to make sure that our database is able to terminate the tunnel, and the tunnel can be terminated on either the database host itself or a separate host, which could be the tunnel server. You can actually create an IP allow list. So the second step to SSH tunnel is to make sure that you have an IP allow list so that it's using SSH, which is generally on TCP port 22. And using the SSH tunnel is pretty straightforward. You can do is you'll have to get your SSH keys, so you'll have to generate some private and public keys to do so. And it's just like any other tunnel that you might see when using SSH to connect to another server. This is what's going to keep the two systems connected to each other. But after that, you can go ahead and use OpenSSH or OpenSSL command line tools to generate your keys. And then you can store those private keys securely as part of the Datastream connection profile. And then you can add the key manually to the host file. And then from there, you should be able just to connect directly, just like with any SSH. Here's some VPC peering is another one that's useful. So this works by creating a private connectivity configuration. And so this means that the data stream is going to use this configuration to communicate with the source over a private network. And this communication is going to happen through what's called a virtual private cloud or a VPC peering connection. Here's some advantages here is that this is easy to configure and it's secure, but it requires a private network connection or a VPN between the database and Google Cloud. So using private connectivity is a connection between your VPC network and the data stream's private network. This means that you have to have an existing VPC that's required, and there must be an available IP range with what's called a classless interdomain routing or CIDR block of 29. So this is where if your project is using a shared VPC, then you'll need to enable the Datastream and Google Compute Engine APIs to grant permissions. And so this connectivity is created, and then you're able to use this if your source database is external to Google Cloud. Then using this private connectivity will enable Datastream to communicate with your database, specifically over a VPN or an interconnectivity tool. So this is how this works when we're using a private connectivity or VPC peering, or even if we can use an SSH tunnel or IP allow list. This is how we can connect Datastream to our source data. In this video, I'm going to show you how we can actually do some work with the change data capture service known as Datastream. Now, to use Datastream, we're going to create some connection profiles for our data sources and our destinations, because the whole concept of Datastream is so that we can actually do this change data capture between the source and the destination, and those two things require a connection profile. I'm going to show you how to create a connection profile here so that we can define the connection parameters that are needed to access the data source and the destination. So we're going to need two different types of profiles, a source connection profile and a destination connection profile. The first thing you're going to do is you're going to navigate to your Google Cloud console right here, and you're just going to look for Datastream up at the very top in the search, and you're going to click the first one that says Datastream, Streaming Ingestion, and Replication. Go ahead and you'll be met with a page that might ask you to enable an API because it's not enabled by default. And once you've enabled that API, you should see a page that looks like this. And what we're going to do here is we're going to use the left-hand navigation bar to select connection profiles. Let's go ahead and click connection profiles on the left side, and you'll be met with a page that looks like this. Right now, there are no connection profiles created at all. And what we want to do is we want to actually create these profiles, and we're going to click create profile up at the very top of our page next to connection profiles. And this is where we're going to be met with a page that looks like this. Now, what this is doing is there's templates for us to use so that if we are trying to connect to MySQL or Oracle or PostgreSQL or SQL servers or BigQuery or cloud storage, these are all different types of sources and destinations that are supported by Datastream. So I'm going to say if I had a PostgreSQL server that I want to use as my source, I'm going to select PostgreSQL so I can create a connection profile to stream those changes. Let's go ahead and click connection profile name. So this is where we're going to define some connection settings. And this is really important because I get to define where this connection is going to live. So for example, I can go ahead and choose my profile name. I'm going to say my first profile, like that, all one word. And I get to choose where they are. So the streams and their associated connection profiles must reside in the same region. So if I want my stream to live in Iowa, then my profiles both have to live in Iowa as well. And then what I'm going to do is I'm going to then give some connection details for my PostgreSQL database that I have connected. Now this comes just from our connection string, goes outside the scope for actually setting this up, assuming that you already have a working database, but this is already done. You'd have it hosted either in the cloud or on premises somewhere that is accessible, and you then have to provide a label. Now, I can also define a connectivity method. So for example, I can use an allow listing, or I can use a forward SSH tunnel, or I can use what's called a VPC peering. So I can access within Google's network or over a VPN if I choose to. All of those are comfortable, so you might want to use whichever one will be the most secure. I've always used forward SSH tunnel. It's the most secure way to actually set up these profiles so that I know that my traffic is going to be encrypted and secured. And then once you have all of this selected, you can actually test the connection profile itself and actually run the test to make sure that you're able to connect to your source destination. So that's how we create a source destination profile. But how do we actually connect to a destination profile? So to do that, same kind of thing, we're going to create a connection profile as well, but this time we are going to select exactly the settings where I want the data to live. So if this is going to be my destination, say I have a PostgreSQL profile that's acting as my source, and I want to send some data over to BigQuery or cloud storage, I can go ahead and do that as well and select BigQuery, for example, where I can then also select a connection profile and a profile name and a profile ID, which will probably be my destination profile. It's much easier to set up than our source destination. And then we can actually click create as long as it's the stream and the other profile, the source profile, is in the same region. We should be good to create this. And then if I click create, profile should be created very quickly. And so that is how we can create some profiles. And then we can use these profiles in our stream ingestion step later when we're ready to actually ingest some data. In this video, we're going to describe the life cycle of a stream and the steps associated with maintaining it. Let's first get started with the stream lifecycle image here that we have. So we understand that a stream lifecycle can be in multiple states. It could be in the process of creating a stream and then having the stream created, but not starting. And then we have to get it into start state, for it to eventually be in the running state. When this is running, we can actually pause the stream, and then it being in a pause state, and then also resume the stream back into the running state. Throughout all of this, there's modifications that I can make to the stream itself, and I can also delete the stream. So there's some administrative tasks that can be done on the stream. So with stream management, what we're doing here is we have to first create the stream, and then this stream is going to transfer data from our source database into a destination, but it has to be not just created, it has to be started. So you have to start this stream, and the status of the stream will change to the starting state. What it's signifying here is that the stream is in the process of being started and it's being validated. When the stream is validated, then the status of the stream changes from starting to running. If the stream isn't valid, then the status of the stream will change from starting back to not started, and then you'll have to rectify the problems of the stream. Some more stream management steps. We know that we can also pause the stream, and this means that the data stream doesn't pull any new data from the source database into the destination. And you'll have some data that may continue to be written to the destination because there's in-flight data currently in the stream that has to be done. You can also resume these pause streams at any time. So after the stream is trained of all data, the status of the stream will change from draining to paused. When it's in the pause state, you can actually resume that information, that data stream, to collect information and send it to the source system. A couple more operations that we can do at any time is we can modify the stream. So any changes that we make take effect immediately to the stream itself. And we can also delete the stream. So after we're not using it anymore, obviously removing it from the Google Cloud Datastream service is the right way to go. A couple stream errors that I'll talk about. One of them is that we are in the failed status. This means that the stream encountered a recoverable error, and it's either still active or continuously attempting to run. Failed permanently status is a little different. This is a stream that ran into an unrecoverable error, which prevents it from continuing to run. So basically, it stops running. And this error is really something that should be avoided, especially because it can incur data loss. And so you'll have to address the issues for a failed stream, and the stream will automatically resume, and it'll change back from failed to running. But with a failed permanently, you'll have to actually address the underlying issues of the stream, cause it to go down permanently, and bring it back up. So that is how we can recover a stream, and just some of the actions that can be performed on a data stream. In this video, we're going to configure a basic data stream so that it's set up with BigQuery. And so setting up Google Cloud Datastream to replicate data from a source, for example, it could be a MySQL database, it could be a PostgreSQL database. If we want to move that data into a BigQuery, and there's several steps that need to happen. So we're going to first get started with these steps. We're going to be creating some connection profiles, stream configurations, and just making sure that we have the necessary permissions to do some operations across BigQuery and cloud storage. Let's go ahead and get started with the Google Cloud console. So we're going to be met here with the Google Cloud console. First thing we're going to do is we're going to go up to the very top, and we're going to ensure that we have a BigQuery data set that's already created. So I'm going to search up here for BigQuery, and I'm going to select the results that say BigQuery Data Warehouse/Analytics. I'm going to be met with this page. On the left-hand side, underneath my Explorer tab, you'll see that there's a project. That's what my project's called. If I click the little toggle node to the left of the project name, you'll see that there's some data sets that are created, some queries. If I want to create a brand new data set, I can click these three dots right here to view my actions and click Create Data Set. This little page will pop up, and it'll allow me to go ahead and create a data set if I choose to. I can select a region or multi-region, go ahead and fill in the data set ID, make sure that you've got the proper name that you can remember, and click Create Data Set. Now my data set is already created. It's called Sales Data, and inside it has one single table called My Dash Table. So now that that's good to go, the next thing we want to do is we want to make sure that we have our cloud storage bucket. Now, Datastream is going to use cloud storage as an intermediary for data before loading it into BigQuery. So to get the cloud storage bucket created properly, we're going to go up to the very top of our search bar, and we're just going to search for cloud storage. Like this, Google Cloud Storage, and you'll see here that it says Cloud Storage, Enterprise Ready, Object Storage. This is the one that we're looking for. Go ahead and click this, and we'll be met with the page that looks like this. Now, I already have some buckets that are already created, and we can actually create a brand new one. Let's go ahead and do that so we can set up a cloud storage bucket. So I'm going to click Create, and then I'll be met with the page that's going to help me fill out what this bucket is going to do. So I'm going to create my bucket. So I'm going to enter a name. So the name of my bucket I'm just going to use is Datastream bucket, like so. And then I'm going to go ahead and click Continue. Looks like I already have this bucket, so I'm just going to call it Datastream bucket 2. This, and now we've got that ready to go. Now, what I'm going to do now is select my location type. I can choose a location type as a region or multi-region. For now, I'll just leave it as multi-region and click Continue. And then I can choose a storage class for my data. I'm just going to leave it as standard for now. And then I'm just going to click Continue. And if I scroll all the way down, you'll be met with how are we going to access control some of these objects. Let's make it uniform. And now I'm at the very last step where I can go ahead and click the Create button on the bottom left. And this is going to create some bucket information. Now, it says public access will be prevented, and that's fine. So I'm going to go ahead and click Confirm. If that happens, it's just to make sure by default that nobody from the internet will be able to access your bucket. If you choose to, you can actually figure out how to turn on those permissions later. But for now, it's by default turned off. Okay, so now our bucket is actually shown here. It's called Datastream-bucket 2, and this is what we're actually going to be using as an intermediary. The next thing we want to do is now actually configure our Datastream connection. So this is where we want to go to Datastream and start creating some connection profiles. So let's go ahead, Datastream, like so. And so we're going to be looking for Datastream in the search, and we're looking for streaming, ingestion, and replication for Datastream. And we'll be met with our page, and it'll look something like this. Right now, there are no streams that are created. That's fine. On the left-hand side of our bar, you'll see that there's a connection profile. Inside of the connection profile, this is where we can create our destination and source profiles. So I'm going to go ahead and create a brand new profile. And at the top, I click and create profile. And I'm going to say, okay, I'm using a PostgreSQL connection. So now I can actually provide a connection profile name, a connection profile ID, and I can also use a host name or username or password. And this is the host name and username and password and database of my system that I'm using as the source database. Now, what's interesting here with this thing is that in my host name and my username and my password, this comes from the connection string of the database, my PostgreSQL database that I'm going to be using. I don't have this part set up here for the purpose of this example, but this could be an on-premises database, or it could be one that's already in the cloud, but you want to make sure that it's publicly accessible. And so once you have that, you can go ahead and click Continue, and you should be able to create the source profile that we need. The next thing you want to do is you want to be able to create a destination profile. I've already created a destination profile for BigQuery, but I'm going to go ahead and show you how to do that again. The BigQuery here is going to be met here. This is going to be either a source or a destination. So to make it a destination, we'll select BigQuery, choose a connection profile name here. Let's give it example BigQuery connection. And so this is what we're going to use here. We're going to go ahead and click Create at the very bottom. And so this is going to be a BigQuery destination file. And now what we're going to do is we are going to go back to our streams section, and we're going to create a stream. So using the left-hand side, let's go ahead and navigate to a brand new stream. Now, creating the stream here requires that a database already be set up as our source. Now, this example doesn't have one created, but I'll walk you through the steps on how to actually use one. So if I click Create Stream here at the very top, I can create a stream name and a stream ID, and then I can define my source and my destination. So let's go ahead and just walk through what that will look like. So if I go example-stream, and our stream ID is going to be example-stream. Very important that we use US Central 1 Iowa simply because the profiles that I've created are in that region. So make sure that your stream and both your destination and your source profiles are created in that system. Now I can choose my source type. My source type is going to be a PostgreSQL database if I choose to, and my destination type is going to be a BigQuery box. Okay, so that's really important that I select what type it is. Now I can go ahead and click Continue for that. Now it's asking me to define the connection strings for my system. For now, I don't have that because my database is not, we don't actually have a source database for this example, but this again is where I would enter the connection for this database as well as its profile name and its profile ID that I would need to use. Now, if you've created one in the previous step, all you'd have to do here is actually select it as your test source. And from there, you can actually go through the system as a whole, and you can define a destination and configure your destination all the way through, and that will actually get your database to be operating properly. Now, once you've created your stream, from this step, you can go ahead and click Start at the very top, and then this is where we can actually get some data flowing through here. So that is a little bit on how we can actually create a stream this way. It's a little difficult to do because this actually requires a source destination and a source profile and a destination profile. So you'd actually have some data stored somewhere, a massive amount of data this way. And by doing so, you'll be able to create a stream from scratch. In this video, I'm going to show you how we can actually create a connection profile to connect to a Google Cloud storage bucket through Datastream. And so this actually is very simple for us to do. So what we're going to do is actually go up to the very top and search for a Datastream on the Google Cloud console. We'll be met with a page that says Datastream, capture and replicate data from different sources. We'll go ahead and click that, and we'll be met with the product page for Datastream. Here's where all of our streams will exist. And really what would matter here is not the stream itself to create, but the connection profile for this bucket. So what we're going to do is we're going to click connection profiles on the left-hand side, and we'll be met with this page where we can actually create a connection profile so we can represent all the info you need to connect to a data location, whether that's the source or destination. So at the very top, we're going to click create profile, and we're just going to select cloud storage. And then from here, we can choose a connection profile name. So I'm going to call this example storage profile, like so. I'm going to make sure that it's in US Central 1, Iowa. And now I can actually connect to the bucket that I want to choose. For example, I have Datastream bucket 2. By clicking browse here, I can now select this bucket as my destination for this storage profile. And I can even select a profile path or prefix that either needs to start with a slash. So this tells me exactly what path in the bucket that I want to use. So if I just leave it like this, it's optional. If I just leave it empty, it's just going to be the whole bucket. But if I want to maybe say, okay, I want to use a folder inside of this bucket, maybe call it destination data, like this. Destination data, there will be a folder inside of this bucket called destination data that all of this data is going to actually be stored in this way. That's fine for now, so I'm going to go ahead and just leave it as blank. And now this connection profile is going to be created. Now that this is ready to go, what you can do from here on out is actually go into the stream section and then actually start to try and create a stream. Now, creating a stream involves both a source and a destination. So I'm going to go ahead and just give it a stream name here. I'm going to give it example storage stream, and I'm going to choose a source type. I'm going to choose my source type to be a PostgreSQL server and the destination type to be cloud storage. So this is where I'm going to take data out of a PostgreSQL server database and then start using a change data capture and sending it over to a cloud storage bucket. I'm going to go ahead and click continue. And here's where it's going to ask me to select some profile names. So I can do something like this. So I can actually create a connection profile if I need to. And so these represent the information required to connect to a data location. So I can actually use the US Central 1 region if I choose to, but for now I'm in Iowa. So I can go ahead and use US Central 1, make sure that that's connected properly. Go into here and it's going to ask me to connect to the database source. Now my database source doesn't exist in this case because there's no database that actually stores any data. But this is where I would take my connection string and actually use this as my source connection. For now, this is going to give me a stream that's useful, but because there's no database that's created for this example, I can't actually continue to use PostgreSQL as a server, but this comes from your connection string. You're going to go ahead and create this like any other connection profile that we've been creating with a profile name and a profile ID, and then you will move on to actually use a source destination system. And that's really it. That's all you need to do, and that will actually fix the error completely. But this is going to be a little bit tricky to do, to actually demonstrate this, if you don't actually have a database that's created for this system. Now, once you have this connection profile created for your database and you have a connection profile created for your bucket, all you have to do now is just define a destination, configure your destination if needed, and then you'll actually have a stream that's ready to go. And then from now, that's exactly how you'll be able to create a stream. And this will take data from a PostgreSQL database directly into a BigQuery or a cloud storage destination. In this video, we're going to identify the choices that affect cost when using Google Datastream. So Datastream is going to stream our data in a couple different ways. One way is called the Change Data Capture, or CDC. So this is known as a way for us to have an ongoing system that's going to capture any changes from the source as they're happening in real time. And we do this in backfill. Backfill is another way that we can actually capture any changes. And so this will take a historical snapshot of the data that exists in a table and then move those information to the source, to the destination. And this basically is a streaming method, and they're each charged at a different rate. So we'll be talking a little bit about how that works in terms of their cost and which one's more expensive. So the data stream pricing breaks down based on the processed number of gigabytes for your data. So it's going to be based on how much data you're processing, and it's also based on the usage billed per byte per stream. And this is on a per stream basis. And so this is going to be stated in gigabytes. So if you see that it's 500 megabytes, you're going to actually see that it's 0.5 gigabytes, for example. A couple things that we want to talk about when it comes to data stream pricing is that bytes are tailed based on raw, uncompressed written data, and that's what's going to be written to the destination. And so there's no additional cost for running streams other than our data process, and you'll have an idle stream that doesn't occur any cost. So it's not like you have it turned on. That means there's going to be charged based on the compute time. No, it's actually based on how much data you're using the stream to process and store. And that's what's going to actually get your cost. So understanding the pricing knows that it's all tiered, so prices drop as your usages increase, and that's very useful. So the price per gigabyte will decrease as you have more data that you're processing. So this reduced price will only apply to usage within the tier. So the gigabytes processed in lower tiers will be charged based on the cost for that tier. And so that's a little bit how that works. So we can talk a little bit now about the backfill pricing. So backfill uses a flat rate. So before we were doing it on a per gigabyte basis, but a backfill will use this flat rate, but the first 500 gigabytes each month is free. And depending then after what region you're working in, you're going to be paying for everything after this 500 gigabytes based on a certain rate. For example, there could be backfill for usage above 500 gigabytes to be somewhere in the 46-cent range USD, depending on the region that you're doing. So here's some other Google Cloud resources that are affected by this. So the cost of data processed by our data stream is one cost, but you're billed for any resources that you're used to transfer, store, or process your data. So this could include things like BigQuery or BigQuery Change Data Capture, CDC, or you could have cloud storage, which is the flat file bucket, a data lake storage for your files. You could also be incurring costs for data flow itself for any transformations, and networking costs if you're moving data between regions if necessary. So that's a little bit about how these cost structure will work for both backfill pricing and CDC pricing. And notice how the CDC pricing is actually being charged on a per gigabyte basis on how much data you're transferring with your stream, and backfill pricing is actually a historic dump, but you're using 500 gigabytes free every month. Afterwards, you're paying a flat rate per gigabyte that you use. And that is how we can use Datastream and sort of keep track of the costs that we're working with. In this video, we're going to identify some common issues that can arise when working with Datastream and how we can troubleshoot them. Let's first understand what these Datastream issues are. Well, when we're working with streams, you might see that there are going to be some errors, and could occur at runtime. And so some errors, such as bad passwords on a database, they're pretty recoverable. those errors are easy to fix. So you can fix them and the streams will resume automatically. But there are other errors that may affect a single object or multiple objects. And this could be an event that contains unsupported data types, or you could have other errors that could impact several objects or the entire stream in possibles, right? So when Datastream can't connect to the source database, that's something that we have to make sure that we're able to handle. Now, information is provided in the streams or the streams details page, and this is where you can actually see what's happening in the UI, and you can retrieve information about the error itself and what you can do to fix it. Here are some general troubleshooting steps for Datastream errors. To troubleshoot an error, you want to navigate the stream and then to view the error itself. And you want to follow the steps that are indicated in the error message to tell you how to actually troubleshoot them. In fact, it makes it pretty easy for us to diagnose the issues right inside the Google Cloud Console. Here's how we can actually troubleshoot the stream. Troubleshooting a stream just means that we go to the streams page, and in there, you're going to find the status checkbox on the data stream. So you could have failed for an error that occurs on a running stream, or you could have failed permanently for a stream that cannot continue to run, so it's basically stopped. And then once we identify what those errors are, we can address them and then fix the failed stream so that it can automatically resume, or we can even recover the failed permanently stream. Now, recovering a stream is, we want to try and recover what's known as the current position. So recovering a stream from the current position fails, then we want to try doing a couple of things. One thing I can do is I can drop or truncate the affected tables in the destination, and then I might need to do this because while the stream was down, and so Datastream might have missed some delete events, and so delete events can't be recovered if you don't truncate the table before you try to do what's called a backfill. I can recover the stream from the most recent position, so if I'm using PostgreSQL, for example, I can recreate the slot or create a new replication slot if I need to. But once the stream is running, it'll trigger a backfill to restore all historical data. And then this is how it can actually be done to recover the stream. It's basically just restarting or removing the error or any type of erroneous data inside of the destination table. And then that's how you're going to be able to recover the stream if it's failed permanently. Here are some more common sources for issue diagnosis. One common thing that you'll see is that there's configuration connectivity errors, meaning that there's most likely a connect networking error, some type of VPC is not properly configured, and that's something that you may have to check, or you may have to update the credentials to actually connect to the source or destination database. Another thing that you'll notice if you're doing on-prem is that you could have some issues with Oracle. So if you've got some Oracle database, you'll see that there's an Oracle error there, and that is one of the causes for this system. So you could have like an Oracle connection profile that you're creating, and it may take a few minutes to change once you've noticed that you're trying to connect to a different policy, for example. So Oracle and Datastream usually works hand in hand, but you will have to make sure that there are some couple things that you want to make sure that you're addressing before you continue. So you'll have something known as an error fetching ongoing. So if you're using it like a change data capture with an Oracle system, and so this can happen if the supplemental logging configuration is incorrect on the source database. So you might want to verify that the supplemental logging is configured correctly, specifically confirm that the logging is turned on for the database tables that are being streamed from the source into the destination, and you'll see that the stream will resume automatically. You're unable to resume a replication as log position is lost, which is important. There's a few different errors that can occur like that when it comes to an Oracle system, an Oracle source. But really, this comes down to the most thing is that when you're working with on-premises database with Oracle, you want to make sure that your logging is turned on for those systems so that can effectively move information and remember its position in case you need to restart the stream. So a couple common sources for issue diagnosis as well that I could talk about is MySQL errors. So this can happen for continuous MySQL streams. If you have bin log that's configured improperly, you'll have something that's unable to resume replication because bin log position is lost. This error can occur when the replication process is paused for a long time, and this causes this bin log position to be lost completely. So streams shouldn't be paused for periods of time that approach the bin log retention period that you configure. You will have to recreate the stream if that happens, and failure running the stream because of incompatible source database and destination versions can happen. And you'll also see that there's PostgreSQL errors as well that can be an issue. And so one thing that you'll see is that a replication slot does not exist. And so this is an error fetching ongoing CDC or change data capture that can happen if the replication slot doesn't exist on the database. So you have to verify that the replication slot is configured correctly, and then you'll have to make sure that it has the correct plugin and you're not using the wrong plugin, because that could actually cause some issues as well in the PostgreSQL stream. A couple more common issues that I want to talk about is SQL server errors. So this gets a little bit different here. So SQL server errors are a little different. So this is known as, some of the troubleshooting steps you might see is that CDC is disabled for the database that you're working with when it comes to any type of SQL server. Change data capture must be enabled for the database, and so Datastream will need to direct read access to the transaction logs in order to replicate real-time changes to the source database and to get compatible, complete log information as well. So you'll have to just enable CDC for the database and try again. That's the most common thing that I've seen with SQL servers. And if you're also trying to retrieve information with tables with CDC that are disabled, meaning that the table level, you'll have to make sure that CDC is enabled for it as well. So this has to be enabled for all the tables included in your stream that you're trying to capture. Another thing that it's not just with these SQL Server or MySQL or PostgreSQL, but you also see some errors coming from BigQuery. So this comes down from if you're using a BigQuery unsupported primary key change. This just means that you're failing to write a BigQuery due to an unsupported primary key change. And so adding primary keys to existing tables is not supported. So if the primary key is changing in the source, you have to drop the table in BigQuery and initiate backfill again all over again. And so this is a limitation of BigQuery itself, not Datastream, but there's really no way to ensure correct merging of new events to that are using a different primary key. So that's a little bit about some of the common sources for issues in when it comes to Datastream and how we can actually correct them. So in this course, we've examined how to implement Datastream to efficiently manage data flows between various sources and destinations, ensuring seamless integration into BigQuery and cloud storage. We did this by exploring Datastream sources and destinations, network controls, and creating connection profiles, stream lifecycle and management steps, near real-time replication with Datastream, and stream changes with Datastream to a cloud bucket, pricing, and troubleshooting a Google Datastream. In our next course, we'll move on to explore how to use Dataproc, Data Prep, Data Flow, and Data Fusion to efficiently manage and optimize data pipelines, ensuring a comprehensive understanding of big data processing tools and their cost implications.